A few days after its close approach, more and more people were able to spot 3I Atlas clearly on the opposite side of the Sun. As days passed, 3I Atlas became even more visible, and some observatories captured truly stunning images of it. Take a look at this new image of 3I Atlas, captured on November 10, 2025. What scientists noticed here is truly fascinating. They observed complex jet structures shooting out from around the object. New data now shows that 3I Atlas has developed a long tail, just as predicted earlier. However, what's surprising is that it also has another tail facing towards the Sun, something completely unexpected. It showed multiple jets extending nearly 1 million kilometers toward the Sun and about 3 million kilometers in the opposite direction. That's an enormous distance, far larger than what we usually see from any comet. After analyzing all the new data, scientists realized that something very unusual happened to 3I Atlas when it passed closest to the Sun at its perihelion. Here's the strange part. By studying the jets, scientists calculated that 3I Atlas must have lost around 16% of its total mass during its close approach. That's a massive amount of material for such a small object to lose. But then came the real puzzle. At its perihelion distance, the Sun was delivering about 700 joules of energy per square meter every second to the object's surface. Based on this, researchers estimated that 3I Atlas would have needed an absorbing surface area larger than 1,600 square kilometers to lose that much mass in the short time it was near the Sun. And this suggests that 3I Atlas should be around 23 kilometers in diameter. But earlier, Hubble Space Telescope observations had already confirmed that the object's actual diameter is only about 5.6 kilometers. So now the big question is, if it's that small, how did it absorb enough energy from the Sun to evaporate so much material? What really happened to this interstellar object near the Sun? Well, according to Professor Avi Loeb, there might be an explanation. He suggested that 3I Atlas could have increased its surface area during perihelion. And if it's a natural comet, there's really only one way that could happen: through disintegration. In other words, the dramatic brightening and mass loss we saw near the Sun might actually be evidence that 3I Atlas broke apart. If it fragmented into smaller pieces, that would greatly increase its total surface area, allowing it to release more material and energy. Based on the calculations, it would have needed to break into at least 16 pieces or possibly more to match the observed mass loss. That would mean that 3I Atlas literally exploded near the Sun, and what we're seeing now could be the after effects of that cosmic explosion, the fireworks of a shattered comet. If 3I Atlas is indeed a natural comet, this new image strongly suggests that it was destroyed by the Sun's intense heat during its close pass. And scientists believe that in the coming weeks, the Sun's tidal forces, its immense gravitational pull, will continue to separate those fragments even further. Astronomers have observed this with several comets. For example, Comet Shoemaker-Levy 9, which broke into multiple pieces before colliding with Jupiter in 1994. Earlier, when 3I Atlas showed non-gravitational acceleration near its perihelion, scientists tried to explain it in a simple way. They thought that maybe as the object came close to the Sun, intense solar radiation caused it to release a huge amount of gas. And that sudden outgassing might have given it an extra push, making it move faster than expected. Based on that idea, Loeb predicted something interesting.
So that means when we look at 3I Atlas after it goes out of hiding behind the Sun, and that should happen within a week or two, if it's a natural comet, we should really see a very bright, massive cloud of gas around it. If we don't see that, the question is what propelled it? And there is no way out, one way or another.
But when scientists actually looked at the post-perihelion image, they didn't see that big cloud at all. In fact, 3I Atlas looked almost the same as before it approached the sun. No thick gas cloud, nothing that showed signs of massive material loss. This unusual change hints that 3I Atlas might have partially disintegrated when it passed close to the sun. But wait, this new possibility raises an even bigger question. Could 3I Atlas be something more than just a comet? Professor Avi Loeb pointed out that it's unlikely to be a mere coincidence that 3I Atlas is behaving exactly like a spacecraft as it moves closer to Earth. He suggested that 3I Atlas might not be a natural object at all, but a spacecraft from another civilization. According to him, this interstellar traveler could be capable of releasing mini probes while passing through our solar system. According to him, if the object really broke apart near the sun, the disintegrated fragments could soon separate completely, and some of those pieces might even head toward Earth's direction, similar to a mothership releasing mini probes.
Well, there are two possibilities. If it's a technological object, then it may release some other objects that reach the planets, and it will continue along its course.
Professor Avi Loeb says that the long jets observed around 3I Atlas appear to be more like a structured design rather than just random natural behavior. Loeb explained that technological thrusters, unlike natural comet activity, require much less mass loss to produce the kind of powerful jets seen around 3I Atlas. For example, chemical rockets expel gas at speeds of about 3 to 5 kilometers per second, which is nearly 10 times faster than the maximum speed of gases naturally released from a comet's surface by sunlight. In other words, if 3I Atlas were truly using some form of technological propulsion, it could easily explain all the observations like the sudden bright glow, non-gravitational acceleration, and the million-kilometers-long jets around it. Right now, 3I Atlas is moving away from the sun, and as it continues to travel outward, its speed should gradually decrease because the sun's gravity is now pulling it in the opposite direction. However, with all the strange behavior and anomalies we've seen so far, 3I Atlas is now coming closer to Earth than ever before. That's why it's important for scientists to observe it carefully and keep monitoring it, to see whether this object might have broken apart or shown any signs of fragmentation as it moves through space. Even if 3I Atlas is a natural comet, we still need to watch closely to make sure none of the possible fragments or debris are heading toward Earth. Also, the surface material of 3I Atlas is completely different from anything we see in normal comets. Earlier observations showed that when 3I Atlas first entered our solar system, its surface appeared unusual. The outer layer seemed to be made of a different material compared to the inner part. This raises an intriguing question. Did this coating form naturally over its billion-year journey through interstellar space, or could it be of artificial origin? On the other hand, scientists and astronomers around the world are now urging NASA to release the high-resolution images of 3I Atlas that were reportedly captured by the Mars Reconnaissance Orbiter when the object passed close to Mars. With the NASA shutdown expected to end soon, researchers are eagerly waiting to see those images. And many are wondering what NASA might be keeping under wraps about this mysterious interstellar visitor.